from University of Leeds. And as I introduced, that he is just not a name, he is a brand in this area. What he has doing the research, and today he is going to talk about the reducing environmental impact of the textile industry. And obviously this research what we are doing together with the help of textile companies in South Africa, as well as the Water Research Commission and other research bodies, including the National Research Foundation, is going to be quite helping. This is going to not only help us in terms of improving the ongoing collaboration and everything, but also to take the research to the new level. Obviously, I acknowledge in the audience, like we have from the industry, many peoples, including Dr. Bombay, Dr. Sean Moore, I think Dr. Smith, and many of the researcher who is there. Fortunately, and I have to thank again to Prof Lin to avail today, and this is a privilege for me to again welcome you on behalf of IEEE Nanotechnology Council and Academy of Nanotechnology and Wastewater Innovation, and obviously your time for giving this lecture. So over to you, Prof Lin.
Right. So I've just actually shared my screen as well. So you can, if you can share yours, I think everybody should be able to see mine now.
Right.
Yeah. Can you see my screen shared?
Yes, Prof.
Yeah. Okay. So we okay, are we?
Yeah. Should I stop from my side?
No. I think I shared my screen now, so everybody should see my screen now.
Yes.
Yes.
Yes. Please proceed.
So excellent. Thank you very much for several things. Now I was going to thank only one, but I've got a few to thank now. So thank you very much for that introduction, and thank everybody for that tremendous patience. We've actually spent quite a lot of time trying to get it to start, and it's entirely my fault because, as you can see, I'm old and not so good with technology, and my computer is on its way out as well. So there are several problems we have, but good thing that we are getting going now. So thank you for your time to come and joining me with this hopefully interactive session. And so depending on where you are, it could be good morning, could be good afternoon, and I've certainly over the next 45 minutes or so's time, I want to share with you our thoughts on various possible routes that might help textile industry to reduce negative impact on environment. So this talk was put together by Dr. He and myself, but I got a shorter straw, so I'm the one presenting to you now. And so in the talk, if all goes well, I would like to share with you three aspects, and with a bit of focus on the technologies and examples of technologies that hopefully will be able to help significantly reduce the negative impacts of textile industry on the environment. So if you are not terribly familiar with the UK, I put together a map for you. This is UK map, and Leeds is round about in the middle of the United Kingdom, and Leeds is within Yorkshire, a county, and Yorkshire. A lot of my colleagues, probably apart from my colleagues from Lancashire, most of my colleagues probably would agree with me that Yorkshire is a beautiful county, and because of the lockdown, I'm actually speaking with you from my hometown, which is in Morley. So before I go into the bulk of this talk, I thought I would like to share with you our kind of approach or philosophy or strategy to research and innovation, and we close very collaboratively, very closely with industry, simply to make our research relevant, our effort to be of use to someone. And because of that, we've had to diversify ourselves. So we cover many aspects associated with color. That includes textile, surface coating, cosmetics, etc., etc. But in achieving what we try to achieve, we always focus on groundbreaking research only, and for several reasons. One reason is that we haven't got a great deal of resources, so we want to focus our resources on what we do best, and what we do best happen to be color chemistry or dye chemistry or pigment chemistry. And that also gives us a little bit of advantage, and that advantage is that because we tend to focus in areas which other people feel very challenging and not sufficiently interested. So it gave us a bit of advantage in achieving something that closer to groundbreaking or world leading, if you like. So looking at the title, which says the environmental impacts of textile industry, and I thought it would be useful to share with those colleagues, particularly those who are not particularly familiar with textile industry, that textile industry actually encompasses a very broad range of activities. So all the way, as far as I'm concerned, all the way from dye manufacturing to textile finishing, at least. So when looking at the potential environmental impact of this industry on the environment, we have to look at all these industries as a whole. So, like many other industries, I mean, textile industry is not unique at all in this sense. And so, like many other industries, textile industry is made up a range of industrial sectors, and then of course each sector of the industry makes a contribution to potentially to environment. And I'm quite sure you've actually seen quite a lot of these numbers or statistics. I wouldn't want necessarily to repeat all these, but just to give you a sense that even dye manufacturing industry is contributing to environment in terms of air and water. And the textile industry itself, by that I mean textile pre-treatment, textile dyeing, textile finishing, not including garment industry, etc. So textile industry also makes a contribution to environment, unfortunately, in a negative way. And so because of this huge percentage of share of the total pollution, it has become quite a significant concern for if you like, society at large. The other concern that has arisen more recently is the concern on microfiber. So microfibers are actually shed by many type of textile products, including natural fiber as well as synthetic fiber. And these, of course, when they get into the waterway, they tend to be consumed by marine life, and marine life in turn would actually be consumed by human beings, and there create a problem. So I had some discussion with some colleagues about the concerns on microfibers, and one of the key points that we were discussing was the fact that it is a combination of plastic, and which is very difficult to degrade, and the micro size of the fiber, and the affinity of typical synthetic polymer to toxic organic pollutant molecules within the waterway. So you can imagine that these microfibers, they would actually absorb toxic organic molecules and then will be eaten by marine organisms, and these toxic molecules or reagents will be released into the stomach and to bloodstream, therefore to the flesh. And when the marine organisms are actually eaten by human beings, all these, if you like, in a way, concentrated toxic organic molecules are now released into human body. So that is a challenge. But my talk today would not necessarily focus on microfiber. I'll be focusing on more on the correlation side. So as I mentioned earlier on, it is essential to look at the environmental impacts of textile industry in the holistic view. And so if we look at the whole industry, it starts, as I said earlier on, from dye manufacturing. So you could actually scrutinize the processes involved in the fabrication of colorants, for instance, in this case, dyes. So you look at the raw material, you look at energy consumption, you look at potential recovery and recycling, and the pollution, and also process optimization, etc. And I often come to this view that one of the problems that we are facing, or dye manufacturing industry as a whole is facing, is because we have not necessarily made substantial innovation, I would say, in the past more than half a century. So dye chemistry pretty much remained similar, although improvements have been made, but we haven't made any groundbreaking discovery in terms of dye chemistry, and therefore there is little wonder that we are faced with a situation today that we use dyes that have got intrinsic problems. For instance, if we look at reactive dyes tend to hydrolyze in the dye bath, and until that problem is resolved, we have to we kind of got stuck to the problem of remaining unusable dye molecules within the dye bath, and that had to be dealt with. So my view is that the dye chemistry, novel dye chemistry in itself is a concern, it's a bottleneck as far as dye fabrication industry is concerned. And of course, because of that bottleneck, it actually causes another problem, and that is the problem with the textile dyeing industry. So you can apply the same set of scrutiny to dye application industry and to find out whether there's any way or any aspect that could be improved or optimized, etc., to alleviate the environmental impact problem. But dyeing industry has a huge reliance on the innovations in dye manufacturing industry. So as I said earlier on, if if the problem of dye hydrolysis for reactive dyes cannot be resolved, then textile dyeing industry has no choice but to deal with that problem or being stuck to the problem. So the two, the dye manufacturing industry and the dyeing industry, the two are actually very closely related. But my view is that one industry, and that is the dye manufacturing industry, will be able to play a much more significant role in terms of addressing the environmental impact problem if novel dye chemistry could be developed. Now, so far, the industry has done very well in terms of dealing with the heavily contaminated effluent using conventional technologies, and these technologies have been very well developed for domestic wastewater treatment, and they apply, I wouldn't say equally well, but they certainly apply across to industrial wastewater treatment with different combinations. So all these technologies are all in existence. And on the next slide, on this slide, I have more technologies to share with you. These are not the technologies that I created. It's been around for a number of years, and they've all been very, very efficient. So the strategy that, as we speak, that are being implemented are focused on the wastewater treatment. In other words, how to actually to deal with the wastewater once they are actually created. But as I said earlier on, my view is very much that a much more efficient approach to alleviating the environmental impact problem for textile industry really is the reduction at source. And I'm quite sure you've heard of this phrase many times before. And so there is nothing new. However, the challenge is in the implementation. And in other words, is it possible for us to use our intelligence to reduce the pollution or environmental impact at source? Now, for dyeing industry, that translates to dyes that will give us higher exhaustion, will give us higher fixation, will give us greater color strength, and therefore we are able to use less dye, etc., less chemical, etc. So, and if we can actually make sure that the dye itself does not hydrolyze, then we would also stand a good chance of being able to actually reuse the dye bath. At the moment, we cannot, because reactive dye, for instance, would simply just hydrolyze, and it just cannot be reused. And so, by the way, on the right-hand side, I've got a few little drawings there just for the benefit of people who are not familiar with textile dyeing. So you start off with a piece of fabric, a dye bath, and then some dyes in the dye bath will be taken up by the fabric, and so you end up with a dye bath or used or spent dye bath that has a lower concentration of dye within it, and hopefully after you've gone through the washing process, there'll be very little dye coming off the dyed fabrics. So ideally, you want this to be almost colorless, and if you're very, very clever, you want this to be almost colorless as well. The question, of course, is it easy to achieve, or is it achievable at all? And my feeling is that many will probably say it's close to unachievable. But let's see. I think you probably see from some of the examples that it's not entirely unachievable. Whether it's actually can be achieved 100% is a different matter. So from this point onwards, I want to share with you 4 examples that I thought might have a chance of helping reduce dye house effluents. So high exhaustion, high fixation, and etc., which I'll go through one by one with you. So the first one is high exhaustion and high fixation reactive dyes. So the idea is if you have a great deal of dyes, dye molecules being attached to the fabric, and if the dye molecules attached to the fabric will be able to fix onto the fabric very strongly, then in theory you would have very little dye, free dye if you like, although unusable dye, but free dyes remaining in the actual dye bath for you to worry about. So then the question is that is it actually doable? And we actually found it is actually doable. It is whether it's actually doable at a cost, that's a different question, but we found it's actually doable. So we played around with commercial reactive dyes and did a bit of modification, and we aim to achieve very high rate, as high as possible, high rate of exhaustion and high rate of fixation. And in this case, I have to emphasize, in this case, we were not aiming at avoiding the use of salt or avoiding the use of alkali. So still use salt, still use alkali, still use similar kind of dyeing temperature and dyeing time compared to the unmodified, we call them mother dyes. And to our surprise, we were able to achieve virtually cast colorless effluent with the modified reactive dyes. So this is a diagram showing you the level of exhaustion achieved under different dyeing temperature. And as you can see, its temperature didn't actually make a huge amount of difference. And so the red one is the mother dye, and the black one is the modified dye. So it's kind of demonstrated to us it is not entirely unachievable. And so this is a diagram showing you the influence of pH on the level of exhaustion. Again, huge improvement was made, and this is the key word, and that is that improvements can be made. And if you actually look at the exhaustion level, it's actually pretty high. And so it's not too surprising we realize that the dye bath, the spent dye bath, was close to colorless. So that was encouraging. And fixation again showed a very good result. The best we were able to achieve is about 98.06. So this is the reason why we were able to see the wash-off liquid being almost colorless. And these are the dyed fabric samples. So on the left-hand side is the mother dye, on the right-hand side is the modified dye, very similar dyeing conditions compared between the mother dye and the modified dye. So different color dye samples at the left bottom, and these are again the blue color. So again, it shows us that it is possible to kind of improve the exhaustion level and the fixation level to such a level that or such levels that would significantly alleviate our worry or our concern about having to deal with heavily contaminated dye house effluent. And of course, you probably wouldn't let me go without pointing out to me that I have not actually paid enough attention to other ingredients within the spent dye bath, and that is salt, and that is alkali. So there is this kind of technology will be able to get rid of, or if you like, reduce the level of residual dyes within the spent dye bath or the wash off, but it cannot deal with the COD as a whole. In other words, there are still other chemicals that are still in the water, which are pretty difficult to actually to deal with once you finish with the dye bath. So we thought it probably need to do a bit more than just getting the dye molecule to have very high exhaustion and high fixation. So we thought maybe we should look at whether it would be possible to dye cotton fiber, for instance, with reactive dyes without any salt or any alkali. And of course, most people probably would say this is absolutely impossible because it defies the very fundamental principle of reactive dyes. Actually, if you look at that statement, you can see that that statement is actually not particularly tight or accurate, because when people say it's absolutely impossible for instance, for the existing reactive dyes not to hydrolyze, it is absolutely impossible to dye cotton fabric with existing commercial dyes without any alkali. That I think when people say that, they are assuming, which is not right. They are assuming that they are following the same chemistry. So if you're prepared to think beyond that chemistry, if you think about a different chemistry altogether, then it becomes entirely possible. But by the way, when I say different chemistry, I didn't mean to cheat a bit using things like cationic dyes, etc. Not at all. I'm talking about still covalent bonding and still absolutely working in this. You can absolutely call it reactive dyes because they are absolutely reacting, and the dye molecules are absolutely reacting to the cellulose molecules through covalent bonding. So they are, as far as I'm concerned, they are reactive dyes. So the secret, of course, is that you might want to make them not hydrolyzing, and therefore you can reuse them, and you want to make sure that you don't require any alkali for that particular reaction. The reaction is different from the reaction of conventional reactive dyes, but this time the new reactive mechanism does not require alkali for that reaction to occur. It is entirely possible because we've proven it is possible. So I put this point here, do not require special pre-treatment of the fabric. It might actually sound to you like very strange, but I just want to put that point there to emphasize that the alkali hasn't been secretly padded onto the fabric, or the cationic anionic treatment hasn't been padded onto the fiber. So there's no such kind of pre-treatment being applied to the fabric, and these are not necessarily the treatments because we're not talking about the same chemistry. We're talking about different chemistry, still reactive chemistry, but different. So because of these features, it was possible to offer a number of benefits, as you can see listed here. And then again, more benefits. I don't want to read them out one by one, as I'm quite sure you can read much faster than I can talk. So these are all the benefits that could be gained if this dye, this type of dyes, is actually used in the dyeing process. And again, as I mentioned for the previous example, these new dyes were based on modification of existing commercial dyes, and the reason we chose to go that route instead of making a new dye from beginning was that we're a bit lazy. We don't want to make dyes from beginning. We just want to use existing commercial dyes, and most of them are actually approved. And as long as your modification, chemical modification to it, is not of substantial scale or extent from chemistry point of view or from molecular structure point of view, it stands a good chance of not having to file for entirely new chemical, which is not a a small, if you like, it's not a small matter at all, even just from a cost point of view. So then we wanted to prove that the dyes actually did not hydrolyze. So we use CE, capillary electrophoresis. For those who are not familiar with CE, it's not entirely different from HPLC, so it's a separation technology. But for CE analysis, you also apply very high voltage across the column or the capillary. In this case, then you add a third possible separation mechanism, and that is separation by electrical charge. So because you have an electrical field, the molecules that carry a different number of charge would move at different speeds. So in addition to mass separation, you also do separation. You can also do separation by electrical charge. And we were very happy when we saw that the dyes did actually, even after a long time of reuse. And of course, this reuse is on the basis of replenishing the dye bath, because you cannot, dye molecules are taken away all the time. So you have to replenish the dye bath before you can do and then the following or the next proper dyeing. So after quite a large number of batches of dyeing, we found that the actual the dye molecules still remained as though as new as the beginning. So if the dye molecules have hydrolyzed, you will certainly see another peak coming out in an entirely different position altogether. So these are the samples of dyed fabric. So this is the mother dye, this is a modified dye, and you can see we also gained on the color strength. And the reason we have that gain is because we know the molecular structure of the new dyes had the structural features that enhances the color. So that is that was a reason. Then the by the way, how am I doing with time? Do I have to finish within the next few minutes? No?
No, you can carry on.
All right, okay. I try to stick to timetable as much as possible. It's entirely my fault, so I've got to correct it somehow. Anyway, so the third one I want to share with you is the so-called dyeing of cotton fibers in supercritical carbon dioxide. And I'm quite sure many of you, if not all of you, have heard about dyeing in textile dyeing in supercritical CO2. In fact, the original technology was invented decades ago, many decades ago, but the technologies have been commercialized by I think a handful of probably less than a handful of companies. And a very, very good one is Dyecool based in Holland. So the process is actually very clever. You can see from this diagram, it basically uses supercritical CO2 as the liquid media to carry the dye. And this technology, and because of this, the process can be zero effluent. So there's no effluent to be dealt with at the end of the dyeing. So the technology has been very successful and been commercialized and worked very well on synthetic fibers such as polyester, but it had always been very, very challenging, and still I think very challenging for natural fibers, and especially natural fibers such as cotton. Cotton is the hardest to dye. So we thought maybe we should actually play around with our hands and to see whether we can actually develop dyes that will be able to dye natural fibers. And so we've had some success. I wouldn't say huge amount of success, a small amount of success. I wouldn't be I wouldn't say that we are particularly proud of what we achieved, because what we have achieved wasn't anything groundbreaking, but I thought I'd probably share with you just in case that it might ignite your interest in that direction in this field. So you can see these are 3 different dyes we made. In fact, one of my PhD students made these dyes, and they perform to this kind of level, so perform better on wool, not as good on cotton, and all the way through. And it's not surprising, because cotton dyeing and wool dyeing are of very different reaction mechanism altogether. And also cotton, in terms of affinity with the with supercritical with CO2, it's very different from wool. So a bit better result on wool, but fairly kind of mediocre to kind of poor result on cotton. I'm still hoping to see that someone else. We haven't spent too much more time after our first attempt, but I'm hoping that other people will be able to get good results on cotton, because it's a very important material in terms of textile dyeing. So this is a plot of the FK value against the temperature, and so it's kind of for on wool it's not terrible, but on cotton it's not. I wouldn't feel proud of these results at all. So cotton needs significant amount of improvement. But the good news is that we're very lucky to find that the dye somehow managed to diffuse through the fiber. So it wasn't all disaster. The challenge was, of course, we didn't manage to get enough into the cotton fiber, and also the conditions that we were using did not cause any noticeable damage to the fiber. And by the way, one thing which I should mention is that the one slight, I would say only very small advantage of our dye system was that we were able to dye at kind of slightly milder conditions compared to the box standard conditions for supercritical CO2 dyeing, or compared to those results published by some of the other researchers. So the last example that I would like to share with you is this dyeing of natural fibers by digital printing. So I'm quite sure you are aware that over the last few years, digital printing of textile as a technology, and also as a measure, if you look at the measure of adoption by industry of this particular technology, last year I've actually seen a huge increase, and I'm quite sure many of you would agree with me, and that the digital printing for textile probably would actually fairly quickly squeeze out conventional printing processes, not entirely, but to a very large extent. And it is because if you were to do the very thorough calculation, you'd be able to end up with some fairly favorable figures towards digital textile printing, and no wonder it's actually if you like being taken up by textile industry in the very embracing way. So we thought to ourselves, well, if this is a few years ago, I think since around about 2015, 2016, I was after the one of the ITMA show. I said to myself, well, it looked to me that digital printing for textile is going to be developing very, very fast, and it's going to be the main printing technology for textile printing. Why is it not possible to use printing to print the same shade on fabrics, so that you can actually get the a process which I call it dyeing by digital printing? Why is it not possible? After all, actually, to print this one shade, in theory, is actually much less complicated than printing a combination of different shades, different colors, etc., etc. From resolution point of view, it should be easier to print one shade than the printing a very complicated pattern, and that will mean you don't need very high resolution printhead. You only need very coarse printhead. As long as the liquid or the dye liquid can actually mix well on the fabric, you should have little problem. So we started looking into this, and then but we very quickly realized that there were problems, and the problems, of course, were, if you look even today, I think if you look at typical dye-based inks for textile printing, you still actually notice these problems. So it still very often it requires reactive pre-treatment on the fabric. Now that partly depending on the ink chemistry, partly is for the cross-linking, and partly is for improving the image definition. So, but quite often the pre-treatment is for the purpose of reaction. So that, in other words, you don't want the reaction to occur in the cartridge. You want the reaction to occur on the fabric. So, but that, as far as operation is concerned, it's not something thrilling. I don't think industry necessarily like that step of applying a pre-treatment on. And secondly, it's still based on its chemistry. It still requires steaming, which is not so attractive, although many operations, factories or textile mills have steamers, therefore it's not a problem. But steaming means condensation, means potential effluent with dyes and chemicals, etc. So ideally, it's not something that you would want to have if you could avoid it. And of course, because it is actually not 100% fixation, it's not surprising, because the chemistry is still the traditional chemistry. It's not 100% fixation. Therefore, you still require washing. Then it's kind of these are starting to defeat the object, because the one attractive feature of digital printing of textile is that you could actually imagine to set up a print shop instead of a textile mill to print textiles. So you don't want to buy a steamer, you don't want a lot of water, a big washing machine to wash and discharge a lot of water, etc. And of course, the other intrinsic problem with dye-based ink is the low light fastness. So these are the features. I'm not saying that they are not the same as the conventionally dyed fabrics. They are the same, but if you are introducing a new technology, then I think in order to overcome, you have more barrier to overcome if you are introducing a new technology. So those barriers may not be a problem for conventional printing, but it is a problem for digital printing or dyeing if you are introducing it into the industry. So these are the problems for the dye-based, and for the pigment-based, there's some problems that some weaknesses of the dye-based ink that have been overcome by the pigment-based ink. However, there are other problems that are still challenging. For instance, it would, in order for the pigment to be able to be bound through the binder onto the fabric, probably sometimes you have to apply another treatment onto the fabric, so the reaction can actually occur more easily without causing too much rigidity. rigidity, of course, is a big challenge for pigment-based ink. And I've seen examples of claimed that the softness has been significantly reduced, but I'm not seeing one that would give you the same softness on a very soft fabric that would be achievable with a dye-based ink. In theory, very, very difficult because you are adding a binder, which by definition, you're going to compromise on the handle. And of course, rub fastness is a concern because the binder may not be very good in terms of binding the pigment onto the fabric, especially if you want the good handle. That binder is not going to be like rock hard. So that is kind of a constriction there, very difficult to overcome. And intrinsically, pigment will have a smaller color gamut than the reactive dye, and that is another challenge. So the wish list is that if we can somehow overcome all these problems, so no padding, no binder required, no seaming, no washing, and it would have pigment-like light fastness, it would have reactive dye-like color brilliance, and that would be ideal. That would really help inkjet printing for textile to take over the dyeing, textile dyeing field as well. So that means the ideal ink would be the ones that would combine the advantages of both dye-based ink and pigment-based ink, and avoiding the disadvantages of these inks. So if that can be achieved, then these inks will have these advantage that they can offer, which hopefully you would actually agree to some extent, at least. And again, more because you don't need seaming and energy saving, and because you're not washing anything away, you help with the color in terms of raw material dyes or colorants, etc. So these are the advantages that could be had if such a coloration system could be created. So these are the examples that I wanted to share with you. And just to finish off, I've got 3 points here. Hopefully, summarize that the takeaway points based on what I've actually gone through with you, and still I find the probably in longer term, and that longer term depends on how long is the longer term, depends on how quickly these technologies can be achieved. And to me, I think digital dyeing, textile dyeing by digital dyeing, done by digital printing process is the one to bet on if I have any money at all. So I hope that I haven't been too boring, and I haven't been wasting too much of your time. And thank you very much for your patience. And if I would be more than happy to discuss with you any views you may have. And I've always emphasized to anybody I speak to, and I think crazy sometimes. So I'm wrong most of the time, but I've been very, very lucky, having been right occasionally in my career so far. So again, thank you very much.
Thank you very much, Prof Lin, for making such a nice presentation and giving the light actually how the textile dyes have a different application. I have applied for some grant in UK, and we were trying to propose the idea of supercritical CO2 for the recovery of metal, but I have not thought actually like whether it can be possible in terms of making use of this super critical CO2 for the textile degradation. And obviously, like you have given a very good light, and that can be also one of the project what we can try to come up together. So that is very good. And I have a few queries what I want to discuss, but same time I want to also give my audience, because they are just eagerly listening for a very long time. So let me just open the floor and then I can just come in. Okay, so now floor is open. Can you just wave your hand so that I should know what question you want to bring it to Prof. Lin? Okay, Prof. Okay, now I see a couple of hands. Now, Mr. Smiley is going to ask. He's working with us as a PhD, and like he's working directly into the area. He's quite enthusiastic to ask you some queries. I am hopeful, actually, like you are going to in quench his thirst. So over to you, Smiley. You can proceed with your question.
Thank you, Prof. I don't know if you can hear me, because the network was just bad when you said Smiley. I couldn't hear the rest.
I can hear you very clearly.
Okay. I only have one question. I've once used the supercritical, but it was for synthesis for functionalization of something. So I just want to know if, because I joined late, if you are also using a microwave to do the coloring when you use the supercritical synthesis method, or you use a different instrument or apparatus. That is my question.
We actually not me personally, and when I say not me personally, I mean myself and my postdoc research fellows, but certainly yes. So I have my students, PhD students, who have actually worked on synthesis using with the assistance of microwave energy. Yeah, so we have we certainly as a whole, we do have a facility and we do have research activities in that direction.
Are you okay, Smiley?
Yes, I'm very much answered. I just wanted to know that I'm very much answered. Thank you.
Thank you, Smiley. Now the next one is Lloyd. He's also working PhD with us, and he might have some queries to throw in the light actually. So Lloyd, over to you.
Thank you very much, Prof. Lin, for this wonderful presentation. Well, I just wanted to understand. You say that it's possible to use reactive dyes on cotton or cellulosic fabrics without the use of salt and possible not mercerization. Now, how does that affect the dye exhaustion or the dyeing time? That's the first question. And then the second one, I know normally with wool, you normally use acid dyes, and then cotton reactive dyes, and maybe basic dyes. But then now the question is, I saw that when using that carbon dioxide one, the reactive dyes were good in wool than in cotton. Could you care to explain why? Thank you.
Right. So just for your first question, the reason that it is possible is because the dyes work on very different chemistry. So when people, as I said earlier on, when people say, well, wonder about how is it possible not to have the alkali and salt to do reactive dye, because they are using, if you like, conventional reactive dyes. The chemistry of the dye defines these are the conditions you have to apply, and of course, you can make it possible by modifying the dye structure, so the functional groups are different, and so the reaction mechanisms are different. And if the reactive reaction mechanisms do not require alkali or salt, then you don't need alkali or salt to do the reaction. And I'm quite sure, I hope that your next question is not going to be, well, can you tell me what the reaction is? Unfortunately, I cannot tell you that, because if I tell you, somebody would be probably seeking for the gun and shoot me. But the reason I share with you, try not to go into detail, is that I just want to inspire other people that it is actually possible. But in order to make it possible, you just have to go away from the conventional reactive dye mechanism. It's a different reaction mechanism altogether. As soon as you know you are in the direction of different reaction mechanism, then you do not have to think about the reaction mechanism along the same line of the existing reactive dyes. In fact, the reactive dyes, they're still reactive by definition, but the reaction mechanisms are very different. So for your first question, and the reason we stuck to reactive dye was because we very much had it in our mind that we probably have to dye fabrics a blend, and I don't know whether it's entirely true or how significant it is, but I've been told again and again by industry that quite often they handle blends, and because you handle blends, you better to have a compromise to use a particular type of dye that will be able to cater for blends of fibers of different origins or different nature, chemical natures, instead of one. So that's why we stuck to what we did. I hope that I've somehow answered, at least in some way, your questions.
Yes,
Lloyd?
yes. Thank you very much, Prof. Thank you. Yes.
You're welcome.
Are you happy, Lloyd?
Yes, yes. I'm happy, Prof. Well, there's a lot I could have asked, but well, I mean, I should give others a chance. Remember, Prof, my background is textile engineering, so I've got a lot of interests in this.
I think.
Well, thank you.
I think Prof. Shivani did mention this, and that is why it is quite good. And obviously, Lloyd, if you have any question, you can still, keep it in your bag. We are going to come back to you again, and because Prof. Lin is still available, and we are going to, chat with him more. Then, as you expressed, let me go to another guest actually, who is also waiting to suit the question. I hope they all enjoyed a lot. So, can I see some more hands? Yes, Prof. Shivani, please proceed.
Prof Lin, thank you for your impressive talk. We are really enlightened by your words and your explanations about your work. Prof, this digital dyeing, I'm hearing for the first time because I think perhaps I had a different idea about digital dyeing. I would be interested to know if this digital dyeing does it differ from fiber to fiber? For the cotton, it should be different. For polyesters, it should be different. And how does it go?
Yeah. I think, thank you very much for your question. I like this kind of question. It's very challenging for me because my gray cells are getting old, so I don't think very fast. But I like this kind of question because it's very relevant and very practically meaningful. So you're absolutely right. So the if we are if we are thinking about maybe making normal speed of progress and looking at a year from now, 2 years from now, or 3 years from now, I think if that is we are actually aiming at, then you will have to, depending on what you want to achieve. So if you remember, I mentioned the both dye-based inks and pigment-based inks. So in theory, dye-based inks will be able to be applied onto fibers of different chemical structure, for instance, because it basically sticking pigment onto the fiber. So it doesn't matter whether it's cotton fiber or is polyester fiber. What you need to do is to make sure that you formulate the inks in such a way that their wetting, etc., is all okay. So, but for dye-based inks, you certainly have to be more restricted, because you would want the best dye, for instance, for cotton, the most suitable dye for wool, silk, etc., etc. So that is for shorter term. So my research objective at the moment is that hopefully we'll be able to come up with a set of ink based on a particular chemistry that will be able to react with most fiber types. So that is what we're trying to achieve at the moment, because to me that would be something like something like, I mean, I don't know whether it's a suitable, appropriate word to use. It's almost like holy grail. So you'd be able to use digital dyeing, but this time your ink can actually react with fibers of different chemical structure, and I think it's actually doable. Obviously the I have to lose a few more gray cells to work it out, but I've got a feeling it's actually doable. So hopefully, if I got lucky, then maybe sometime in future there'll be a dye, there'll be an ink or ink that will be able to do that. Does that actually answer your question at all?
Thank you so much, Prof. I mean, I really appreciate your answer. I should thank you for your kind words. You know, you spoke about my queries. Sometimes I go wild in my thoughts when I think about science, and then when you were talking about this digital thing, so I was thinking like, Prof, is there any possibility to introduce somewhere artificial intelligence which can check which type of dye should correlate with which type of fiber? So there can be, I'm not sure if I'm right or wrong,
well,
but
I think you're thinking much faster than I do. I can tell you that. I know very little about artificial intelligence, but I know it can do a lot of things that you desire it to do, and because artificial intelligence has one great advantage compared to human being is that it doesn't forget, it doesn't age, it doesn't die. So yes, I don't personally, I don't know how that could be used. I'm quite sure it could be used for already on the printing control in terms of spotting the wrong color, etc. That's been used to some extent. But I think what you are saying is a lot more than that. What you're saying is that to use artificial intelligence to make intelligent decisions about which dye that you want, or which ink you might want to develop, that will be able to cope with different types of fibers. That is a lot grander than than I've ever thought. But I so far I'm still relying on my own gray cells, which are disappearing very fast. Still using my own thinking to do it. I think it's just out of maybe of interest to you, artificial intelligence. I kind of I start to get very worried about artificial intelligence, and the reason is because precisely the reasons I mentioned earlier on, because you can imagine artificial intelligence, you can imagine a robot with built-in artificial intelligence, it does not die.
Yes.
And that means eventually it'd be probably better if not the same compared to Einstein. Why? Because it doesn't die. So Einstein, we know he's very, very intelligent, but he dies. And so a baby has got to learn from nothing again to build up knowledge. Just when the guy is very, very creative, he dies. That is a problem. But artificial intelligence does not die.
Yes.
And so its knowledge would be building forever. That is a worry. So if we hand over if we make our artificial intelligence so clever, how long do you think it would take artificial intelligence analyzer to figure out mankind is most useless resource wasteful being on Earth?
True.
To find that out very, very quickly.
True.
Because artificial intelligent robots does not need to eat a great deal. They don't need to sleep. They learn all the time. They don't forget. They don't have disease. They don't die.
Yes.
And it's a human being who think they can control everything. They have to eat. They have to sleep. They have all kinds of weaknesses. So what I dread is that one day you only need one very, very curious scientist to grant that autonomy to one robot. Then we've had it.
Yes.
Because that robot would have to make a very quick decision, figuring out, well, if I were to plan the whole Earth again, I will get rid of human beings straight away.
Yes.
Anyway, sorry, this
No. Thank you so much, Prof. Thank you so much for your comments, and thank you for your time for my query. Thank you very much.
You're most welcome.
Thank you, Prof. Sivati and Prof. Lin. I think that was, very nice, both of you to listen. I think it was a very, very fruitful discussion, and the way you put the thought, Prof. Lin, I think that is the way we are going. Like how you can think beyond actually, and as you have given the example of artificial intelligence, that it is not going to be dying. Even the Einstein can die, but not the artificial intelligence. So that is so nice way you try to bring it.
So there's another thing which I think I'm very, very keen to actually for especially for younger researchers or young researchers to bear in mind is that when people say so and so what and whatever is impossible, that statement itself is entirely wrong. Do you know why? You don't even need to be super intelligent to figure out that statement is entirely wrong. For a scientist to say that is entirely wrong. Do you know why? Because you can only prove something works. You cannot prove something doesn't work. You cannot prove something will never work because you haven't made it work. What you've proven is that you haven't made it work. It does not mean it doesn't work. You haven't figured out how to make it work. So that is why quite often when people say, well, it's not possible, I'm just thinking, how can you say it's not possible? How do you prove something is not possible? You can prove something possible by putting A and B together. You see, that is entirely possible. You've proven it. But you put A and B together, you don't get C, and you claim that A and B to get C is impossible. It's do you not realize you haven't got it right? You haven't done it correctly.
Yeah.
So there's always a possibility that you haven't done it correctly. So that means that you haven't proven logically speaking, you cannot prove something that is not possible. Simply, logically speaking, it's just not possible to prove that. You can certainly easily prove something possible, easily done, because you can see it. Put A and B together, you can see. But if you put A and B together, you haven't got C, you have to ask yourself for a question: have you done it correctly? If you haven't done it correctly, then it's your fault. You cannot say A and B will never get C. And I encounter this kind of question all the time, and that is why I have a kind of a bit of advantage of freedom of thinking, because I do not assume anything impossible at all. I haven't made it work. It just means I'm not clever enough. Keep trying. and hopefully one day you start to work.
Prof Lin, I am so proud to say today that you are so down to earth to make such a nice statement, and also the philosophy what you said. I think this is going to be quite very motivational to the young researcher, which is they are listening your talk and listening your thoughts afterwards. Actually, like the science is where we are going, what we can imagine, what we cannot imagine, and how it can go more further. So obviously, like these are very interesting things. But let me also bring some more queries if I have. And I can see actually Dr. Chobe is here. And in the beginning, I just introduced you like he's the vice president at UPL. He's the company based in India, and he personally wanted to come and meet with you today. So I think let me introduce to him. Prof Lin is right here, and Dr. Chobe is also with us. So now let us start the conversation.
Thank you very much. Very pleased to know you.
Thank you, Professor Long Lin. I was very excited to hear your lecture on textile industry. And in textile industry in India, we are facing several problems related to since it's consume high water, huge water get consumed. So now in India, government is trying to make the ZLD mandatory, and several units are implementing zero liquid discharge, where they can treat the wastewater and reclaim all the water and achieve the ZLD such that the lesser water demand comes in textile industry.
Yeah, so I think the many countries are facing very similar textile industry facing similar type of challenge, but I think the good news is that I've heard from my colleagues. So I've not met these people in India. My understanding is that India as a country has actually been moving very fast in terms of making new dyes. I've heard some report about Indian research institutes, not universities, but private research institutes, making some new, much improved reactive dyes, for instance. So I think hopefully in the future, hopefully is looking good. So in the UK, I think dye research, we certainly are not doing the same volume of dye research as we used to do in the past. I mean, the color chemistry at Leeds used to be one of the leading players in terms of dye chemistry. But so that activity has continued, but certainly hasn't continued in the same volume. That is a problem. So it's not continuing in the same volume. So, but I see that I see India, some research institute have actually continued in a very large kind of volume. So I think in terms of water challenge in water, etc. I've also heard from one of my colleagues. He has companies in India, and so he talked to me about his company business is in making fresh water, drinkable water from polluted water, and so using portable devices. So that is why when I talked to him, he mentioned to me about this huge government initiative or legislation clamping down on the consumption of water, which is very worrying because that means your production is going to be restricted. And I know that in some countries that they would actually apply quota for textile industry. I don't know whether India is already doing that. In other words, they would actually install a water meter at your factory, and they would actually say to you, this month you can only use this much water. If you go over that, we're going to charge you a fortune. So they've been doing that for a long time. So I don't know whether India has already implemented that or India is not doing that.
So actually in India also, those industry who are using groundwater, a very stringent condition is there, and they have to put the water meter, and also they have to take the permission after doing the environmental impact assessment. But those industry who have a industrial supply line, so still they have liberty to use as much as they can use the water. But I think nowadays a sense of sustainability has came in India. Yeah. And if you see, almost all industries are now trying to reduce the abstracted water demand. So they are working to reduce the water consumption in industry. Now today, I came to discuss, when this was circulated, your lecture circulated, then I found Center of Industrial Collaboration. Right. So I want to understand what kind of industrial collaboration at your center happens. So that I want to understand. And before that, I want to give a brief introduction about myself. So I am Ritunjay Chaube, and I am heading globally UPL, Environment, Sustainability and Green Cell. So basically I am a water treatment professional and environmental engineer, you can say. But from last 25 years, I am in the industry, and I worked in Cell at Netherlands. So I used to see the environmental aspect of Cell. Then I moved to Unilever, and in Unilever for a long time, I was in charge of sustainability. And now from last 5 years, I am with UPL. UPL is global agrochemical company, that is 5th largest company globally. And I used to see the operation of all environment, sustainability and green cell inside UPL. So our challenge happens to be that how to treat the wastewater, how to decrease the water demand inside the plant, how to decrease the CO2 emission, how to decrease the waste generation from the entire group. So that is my main KPI. And we always work to reduce all these emissions from the UPL. And last 5 years, we are successfully reduced nearly 30% emissions inside UPL. And 30% reduction means water reduction, CO2 emission reduction, and wastewater reduction. And I am also responsible of publishing the sustainability report of UPL. So every year we used to publish the sustainability report. So there are a lot of things are there. So my question is, and I mean, I want to interact, that what kind of industrial collaboration University of Leeds used to do?
So collaborations in the short sentence, we do a number of different types. So for instance, we do very large research projects. So you've been looking at one project would actually amount to something like £3 million for 3 years. And we also do research projects in terms of collaboration with industry through in the UK the so-called EPSRC. So that is the project is funded by government 66% and funded by industry 33%. And so the IP will be negotiated within the industry and the university. And we also do the so-called knowledge transfer partnership. And that is actually sponsored by government 78%, by industry 28%. And we get a person who will be working closely with the university, but who is actually an employee of the company. So the person is actually paid a salary by the company, but works very closely with a professor within the university. And we, of course, also do consultancy. So the consultancy is very much project-based, kind of topics, and we also do our own research, and our own research usually ends up with the IPs that university would actually own, and we certainly sell technology to industry.
So I think I may need your contact detail such that we can also in future be in touch. And at UPL, we are also looking a lot of collaboration with the leading universities, because we are in process of bringing several green sustainable technology. Yeah. And I am also in charge in UPL green cell. We have created a green cell, and at our green cell, number of engineers, biologists and chemists are working. 2 full-fledged laboratories is also there, and we are working to bring the new sustainable green technology and implement inside the entire UPL group. So I think it will be useful. We will interact in future and see that how collaboration we can do and work with University of Leeds. Another question is how the admission process goes there. If suppose somebody from the India, some students are interested, then how they used to take admission in University of Leeds?
In terms of admission, it depends on which level. So depends on whether you want to do university
undergraduate level.
Undergraduate.
Suppose they want to take admission in engineering, especially in the chemical engineering, environmental engineering, or sustainability.
So you're talking about undergraduate level, is it? Yeah. Right. So undergraduate level, you would apply to the University of Leeds or any university. In the UK, there is the so-called UCAS system. I think in India, is it the same? UCAS. So UCAS system, you would actually apply, and then you basically just walk through the system. UK accepts a lot of applicants for undergraduate every year from abroad. So it's just as soon as you applied for it, then you are in the system, and they will show you every step that you have to go through, and it's very much dependent on your A-level results. And if the A-level result is good, you'll be in. The harder thing is to choose which university and which subject to do. That is harder. That is much harder. But that depends on the individual.
Right.
Yeah. I mean, if you have someone who's very intelligent, I will always recommend you go for places like Cambridge, Oxford, really high-flying universities.
Yeah. Right. I think that was a very nice way to introduce each other. And obviously, like as we are going to proceed, I think Prof Lin, you will agree with me. Like you can provide some more time for us actually, like to have some more session, because you can see the kind of interest is there, and every interest is coming in terms of like. In the common ground of the research where we can come and work together. And obviously with your expertise, I think, this can go more longer way.
Well, hopefully, I think I think it's always useful to make one's research relevant. In other words, we're doing so. If we are finding mutual benefit out of it, then that is something meaningful.
Right. And there is a lot of the calls comes like Horizon 2020, and So those calls is quite important where we need good partner, and this is the way when we discuss in the broader way. I think that's how it can go. I was unlucky.
There are also certainly funding calls for specifically for UK, South Africa,
Right.
and specifically for UK, India, etc. So I think those are the things that would be beneficial for us to keep an eye on because they can be quite substantial.
Right. I can name even today because some researchers are still there in the audience. That some Newton's call come right there, Commonwealth, DFID, those kind of calls come where we come and together, and obviously like India can also come part together. And Dr. Chobe is so keen. Actually, I can see he, he just was a little bit worried, like because of the timing he may miss. But I said no. Prof Lin is going to be here and we are going to ensure we are interacting, So with that note, Prof Lin, because the timing is almost now 2 hours. So I have to conclude, but I want to take a promise.
So Professor Ajay, what we can do, I think, thank you to you for introducing me with Professor Long Lin, and we will be interacting. So Professor, I shall take your contact detail from Professor Ajay, and then we will be in touch because we are looking for some of the industrial collaborations, and we will see that where mutual collaboration can be possible. And our UPL office is at London, so full-fledged office is there. So I think going forward we will see that how the collaboration. We have one collaboration with University of Cambridge. So we have sponsored a foundation there in University of Cambridge for sustainability.
Is it in the engineering department or?
Yes, yes. Yeah. So that detail I shall share with you, and similar things we want to have a collaboration with University of Leeds also. So going forward, I will be in touch, and maybe going forward we can have a team meeting and then we can discuss in detail.
Yeah.
No, that I will ensure we can provide the same way.
Right.
Our conversation
even if you will be interested for your students at University of Leeds, if they want to hear some lecture from the industrial expert, then I am ready to deliver half an hour, 1 hour online lecture. We can share our experience in how we are embedding sustainability at industries and how wastewater treatment we are doing, what kind of challenges industry is facing. So those kind of things we can share with the students of your university.
Even me personally, I would like to learn a lot more from you.
Right. So nice of you, Prof Lin. And
because I'm essentially a chemist, so I'm always eager to learn more from engineers.
Despite the fact, actually, like you already mentioned during your finishing of the talk, it's the hair is growing, and it is going towards the gray side. So rather we can make an impact now. So I remember those words. So obviously, knowledge has no limit, and obviously with the sharing together, working together, collaborating together, we can achieve the best of us. With that note, I have to say thank you very much, Prof Lin, with the promise that I am going to invite you for another session where my conversation is still left, like how supercritical CO2 we were using for the metal recovery. And that is the joint project we will plan together, how we can go with the Horizon 2020 next program.
Absolutely.
Yeah. So on behalf of Academy of Nanotechnology and Wastewater Innovations and IEEE Nanotechnology Council, I would like to thank you very much for your time and your sharing, your knowledge, experience. And I will give you the platform for a final words from you, Prof Lin.
Oh, it has actually been an absolute joy for me to share this session with you, and I most of all I enjoy questions from the audience, and especially from the young ones, that they were able to think a lot faster than I do. It makes me feel very old, but that is how the world is.
Right.
So thank you very much for your time to listen to my talk.
Thank you very much, Prof Lin. And now I'm just going to stop this meeting.
All right, all the best.